So here's standard form for a quadratic equation. It is ax squared plus bx plus c, and we'll just say like f of x equals this. Okay, or y. Okay, and just a, b, and c are numbers. Okay. So then how do we graph this? Well, before we go about graphing these and like understanding how to graph these, we want to remember what, again, what these quadratic functions look like and really understand that. So let me draw a quadratic function. I'm going to kind of try and I'm just sketching this up here. You don't have to be too precise with like, where my coordinates are and stuff like that. But we can have, quadratic functions that look like that. Right? We can also have quadratic functions that look like this, right, too. Upside down, right? What we would expect. Okay. Some things we need to keep in mind, though, about quadratic functions. First of all, okay, because of their shape, they have this kind of like point at the end here. Okay? Sometimes that point is the lowest point, right? So when we talk about like the U parabola, right, like this, then that's like the lowest point or the minimum of the graph. Sometimes this point is the highest point of the graph if your parabola is like a frowny face, right? And what's the name of that special point? Starts with a V. The vertex, okay? If you guys remember back when we talked about graphing absolute value equations, that also has a vertex. The vertex of the absolute value equation is the point of the V, right? That's also the vertex. And so you can kind of think about this, it's not really like a point, because obviously a quadratic equation is not a pointy, it's rounded, but it still has a lowest point or a highest point, again, depending on where it is. And that's the point we really want to locate. Once we can locate that vertex, then we're pretty much good to go about how to graph the rest of it. Okay? Excuse me, okay? Another thing I want to point out, just like with the absolute value of x, okay, there's symmetry too, okay? So if once you get one point on one side of the vertex, you can then use symmetry to get the other side, get a point on the other side too. So that helps cut down on the amount of points we need to come up with, right? Lines, for example, lines are not necessarily symmetric, so you have to come up with a lot of points. But there's a axis of symmetry, so that's what I'll call this thing. This is the axis of symmetry. Okay, and it goes through the vertex. It's just a vertical line that goes through the vertex. That's it. Okay. And so the question is, how do we go from this to then get a vertex and then figure out some more points? Well, the bread and butter, the thing that's going to help us out the most here, okay, is the fact that the x-coordinate, because then the vertex is going to have an x and a y coordinate, right? The x coordinate of the vertex, okay, is going to be this. X equals, oh gosh, I want to make sure I get this right. Pretty sure it's negative b over 2a. Yes, negative b over 2a. Right, where the a and the b that you see right here comes straight from our quadratic function, a and b right there. Okay, so let's do an example here. Let's actually like come up with a quadratic equation here. So let's say I've got, so let's find the coordinates of the vertex of, and we'll do like y equals 2x squared minus 8x plus 6. Okay. Is this ringing a bell for any of you guys too, by the way? Like, is this somewhat familiar? Yes, from Algebra 1? Okay, good. Okay, so let's find the coordinates of the vertex of that equation. Y equals 2x squared minus 8x plus 6. Okay, so again, we're going to remember that the x-coordinate is negative b over 2a. All right, which means what should go into my b here? And this, a negative 8, yeah. So we're going to have negative 8 over, and then what goes in for the a? 2, right, because the number 2 there is my a. Okay, so again, there's my a, there's my b, it's the negative 8, and then there's c, but we don't really use c when it comes to the vertex. So we have a negative 8, which is really then positive 8, and then 2 times 2 is 4, which then just implies to 2. So great, we've got the vertex, we've got the coordinate 2. But my directions here didn't say find just the x-coordinate, it says find the coordinates. That means I need an x and I need to find the y. The c does have an important part, but nope, the y value is not going to be 6 here. Maybe 6. Yeah, plug in the 2 to what, Jake? Yeah, the original equation, exactly right. Remember, the vertex is a point on our quadratic equation here, or quadratic function. Which means if the point on the function, if I plug in 2, then it's going to automatically give me what the y value's got to be. So we're just gonna plug in 2 here. So it'll be then y equals 2 times 2 squared minus 8 times 2 plus 6. And so all we have to do is just simplify that using order of operations. So, and this is something you can type into your calculator too all at once. If you have a graphing calculator, you can just type that whole mess in, hit enter, and it'll give you the answer. But I'll do it here. 2 squared is 4, so it'll be 2 times 4. Minus 8 times 2, I'm going to go ahead and do that too. 16 plus 6, and then 2 times 4 is 8 minus 16 plus 6. So then we go from left to right with that addition subtraction. So 8 minus 16 is negative 8, and then plus 6 is negative 2. And so we get the vertex 2, negative 2. Okay? And so now let's actually graph it. Let's graph y equals 2x squared minus 8x plus 6. Let's do that. Alright, so I know I have to fit 2, negative 2 on my graph here. So when I go to graph, I'm going to put it kind of over to the side here. That way I can do more graphs if I want to. Okay. I'll plot that vertex 2, negative 2, so like right there, there's our vertex. Can anyone tell us if the graph is going to be like the U or the frown here? It's going to be U or a frown. Is that probably going to open upwards or is it going to open up downwards? Upwards. Okay, upwards. What gives it away? Not the plus 6.
The first part.
Yes, the 2. Yep, the very first number here. That is what gives it away. Yep. If it's a positive 2, it's going to be opening upwards. If it's a negative 2, it's going to open, or negative number is going to open up downwards. Very good. Very good. 2 is kind of like the slope. Yes, it does. It kind of works out that way. It's not in the same way that it did for our absolute value. So we want to be careful because the absolute value it's a straight line on one side, it's a straight line on the other side. But for this, because it's curved, the slope we want to be a little bit careful about, right? Because it's not necessarily just like that. But to get more points here, so what can we do, right? Because obviously you can't graph the parabola just with a single point. I mean, you can, but it's not going to be very accurate, right? We need to come up with some more points. And so here's where we're going to just use a t-chart, okay? At this point, we're just going to use a t-chart, okay? So we're going to pick some x values. We're going to pick some x values and then get their matching y values. So I suggest, since our vertex is here at an x value of 2, let's pick some x values nearby. So like x value of negative 1. Okay? I'm not going to pick at the x value 3, because if I get negative 1, then I'll also know the point that's at 3, right, because of symmetry. So I'm also going to maybe use like 0 here too. Okay? Some of you maybe would have chosen to pick like 3 and then like 4. That's fine. You can do it that way too. You can go to the right or to the left. It doesn't matter. But I would not suggest going both left and right, because once you have points on the left, you'll then have points on the right, and vice versa. If you have points on the right, then you'll know points on the left as well. So just pick to one side, either way. There is a pattern, but it can change depending on our A's, B's, and C's here. So that's why I wanted to stick with this table. The table will be more generally useful. With the absolute value, we were able to just kind of use that number in front and then use that to help us. But with there's three numbers that are changing here, so we have to just be very careful. We'll talk, but there is a pattern there. Yes. So anyway, let's plug this -1 in, and this time I'm just going to use my calculator because heck, why not? Okay. So 2 parentheses -1 squared minus 8 times -1 plus 6 gives us 16. Oh my gosh. Okay, that's going to be ridiculous. Okay. And let's see here. And then let's try 0. So, oh wait, no wonder I put in -1. Duh. I don't want -1. I should be putting 1 here. I don't know why I said -1 on the table. I'm sorry, guys. I should have said 1 because that's a positive 1 there. That's my mistake. All right, so let me delete out those negatives. 0. That's much nicer. Okay, there we go. Okay, 1, 0, and then let's put in 0. Now, again, I don't know if you guys know this, and this is just like little helpful tips. You can like completely ignore this if you want to, but if you don't like having to type things over and over again, if you press the second enter button, the calculator will rewrite the last thing you typed in, and then you can just use your arrows to go back and replace the 1 with a 0 instead, right? That's nice. And so, okay, we get 6 now. So that'll save you some time. Okay. Alternatively, if you have like one of the newer calculators, you can actually just arrow up to the earlier thing that you typed, and if you hit enter, it'll retype it there too. And again, you can change the numbers inside as well. Okay. Yes, so there's an alternative to that. Yeah, we can go to our y equals. We can type in 2x squared minus 8x plus 6, okay, into your y equals. Then do second graph, and it'll take you to the table here. Let me go back and change mine to what it was. And so that you can also, use that and just get some points that way too, which will also save you time as well. Okay, so I don't care. When you have the calculator available, folks, use whatever you want. Make it as quick as you need it to be. Okay. Anyway, let's plot these points. So we've got the point 1, 0, so that's going to go right here, and then 0, 6. So 0, 1, 2, 3, 4, 5, and then 6. Okay, and then don't forget about that symmetry, right? We have this like nice axis of symmetry that goes right through that vertex there, and so we can go over 1 to right here, and then over 1, 2, 1, 2 there, reflect it over, and you get a nice graph of that parabola. So there it is. Okay, so to graph, find the vertex using x equals -b over 2a and then pick some x values near the vertex to graph. Use symmetry, okay, to get more points. Okay. So that's standard form. That's standard form. Okay. Would anyone like to see another one of these? Are we all feeling okay about this? No one needs to see another one? All good? Josh, you feeling okay about this stuff? You good? Do you want to see another one of these? You think you need to see another one? Or are you good? Think you're good? All right. We'll move on to another one then here. I'll leave some space down here. I'm going to pass out another graph paper too because I'm running out of room. I don't know about you guys, so we're going to need more room than what I've got left there. So would you like another piece there? Okay. You want another piece? Good. Does anyone want another piece? You guys don't need a base? Jake, you need a piece? You guys are good? Okay. Anyone else? You want another piece just in case? Okay. All right, so that's graphing using standard form. Okay, so hopefully that was just review. If not, that's okay. You can, figure it out. All right, the other way that we're going to be graphing, and this is like the nicer way, I guess I'll say. Okay, this is not the less stupid way. Okay. We'll say this is graphing quadratic functions. So we're still talking about parabolas. We'll still have the vertex. We'll still have the axis of symmetry. Okay, it's just that sometimes we'll be given more information. Okay. So this form is called, this one we're going to look at now is called Vertex Form. And this is one that may look more familiar to us if we remember our transformation stuff that we talked about. Okay? Remember that the parent function here is y equals x squared. Right? And we talked about how we could shift that y equals x squared left or right, shift it up or down, and then also, like vertical stretch or vertical shrink it and stuff like that too. And that's basically what vertex form is. It's those transformations. So it's going to be y equals a times x minus h squared plus k. So yes, essentially, yeah. It needs to be it needs to be x minus h, and then the x coordinate. Yeah, so that'll be the x coordinate. Yeah, it's basically like Mr. Welch's ex-wife Helen, who always lied, as he says. Okay.
Can you tell me about that?
No, I'm going to ask him though next time I see him. But so here though, the vertex form. Okay, we call this vertex form in a similar way. The reason why we call points or slope-intercept form, right? Slope-intercept form, when it's written that way, you can see what the slope is, you can see the y-intercept. Well, when it's written in vertex form here, we can see the vertex as for what it is. The vertex is simply it's at the coordinates h, k. That's it. Okay? Now, standard form and vertex form are not, they're different forms, but they both are talking about the same kind of thing. They're both talking about parabolas or quadratic equations or functions, whatever you want to say. Okay? So, and we can actually convert between vertex form and standard form. We're not going to worry about that right now. We're just focused on graphing today. Okay? The axis of symmetry, what we use to help us get more points, what we're reflecting it over or what it folds over, it's just the line x equals h, right? So it goes, again, just right through the vertex. It goes right through the vertex there. Okay. And does anyone want to guess which one of these letters determines whether the graph opens upwards or opens downwards here? Yeah, Carlos? It's A again. That's right. That's right. If A is greater than 0, it looks like this. And if A is less than 0, it looks like that. Okay, opens downward. I'm just going to use the picture, right? It's easier to draw the picture than it is to use the words there. Okay. And so let's do an example here. So let's graph y equals -1/4 x plus 2 squared plus 5. So this has every piece in it. Okay, I'm kind of throwing this right out, doing like a more tricky one here right away. We're kind of jumping in head first. All right. So what will the coordinates for our vertex be here? Okay, so 5 will be the y coordinate. What's the x coordinate? 5 is the y coordinate. What's the x coordinate? So you're close with 2, but it needs to be what? -2. That's right. Right? It lies, right? It's just like what we said before. That +2, remember, it needs to be a minus h. So if we have a +2, that means it's really minus a -2, right? +2 is really...
Why couldn't you just write the formula without the negative like plus h, and then it would be the same?
No, it would be opposite. So then you would say, if you wrote x plus h here, then you would say that the vertex is at -h. Okay. That would have to flip. You see what I'm saying? So it's up to you. However, you can think of it that way if you want. But yeah, it's always just going to be the opposite, right? And it's just like what we talk about transformations. Right, Jordan? It's like the number that's with the x there is the opposite of what you'd expect it to be. The +2, you think, oh, so let's go right 2. Nah, let's go left 2. And so same thing here. +2 really is then a -2, which makes sense, right? If we're shifting, if we take that graph of x squared, which goes through 0, 0, that +2 means we shift left 2, and there's the x coordinate -2, and we're going to shift it up 5, and so there's where the vertex moves from 0, 0, left 2, up 5, and that's where our new vertex is. So it all is, it all is together there. It's not some sort of, we're not learning separate things here. This is all, one kind of idea that we're kind of putting together. So let's go about graphing this here. So we need -2, 5. Okay. So I'm going to graph this. Because I know that I need to go up a little bit higher on my y-axis, I'm going to draw my x-axis a little bit lower down. Okay. Since my vertex is located, left 2 and up 5, I kind of want to emphasize that third quadrant. If you don't want to have to do that, if you don't want to have to think about that, and you just want to draw, the same, equal on both sides, that's up to you. Okay. That's up to you. But I'd like to, save some space. I also know that we're opening downwards, right, because that -1/4. And so again, I know that I want to leave some space below it, though, to graph from there. All right, so there's our vertex. And so our axis of symmetry is going to be this little, again, you can draw the dotted line in. You don't need to. If you feel like you can just, get it, that's fine. I'm going to draw it in now. There's our axis of symmetry. Okay, so a little bit less work. The vertex, we can just read it. But now at this point, we need to get more points. And so guess what we're going to do? We're going to pick some x values, and we're just going to plug them in and make a table again, okay? So we just need to make another little t-chart here. Okay, and I'm going to pick some x values here and then put the matching y values down. Again, I would suggest picking some x values that are near your vertex there. So maybe like -1, maybe like 0. Maybe 1, maybe 2 as well. We'll see how these numbers work out and stuff, okay? Because maybe sometimes we don't get nice numbers. Okay, and so then we'll go to our calculators and just make sure you type things in accurately. So let's see here. We'll do -0.25, or you can just do parentheses -1/4 if you want. I guess that's fine. And then x is going to be -1 plus 2 squared plus 5. Okay, so we get 4.75. We plug that one in. Okay. Remember, instead of typing it in over and over again, if you want, you can go to your y equals and just type it in there, like Greg suggested. Okay, so we got the -1/4 x plus 2 squared plus 5. Then you go to your table, second graph, and then you can see all the little values. I have to scroll up here, I think. So yeah, there's 0 is going to give me 4, so that's a nice point. No decimals there. 1 gives me 2.75, and then 2 gives me 1. And so then we'll graph that. So let's see, 0, 0, 4 is easy. So 1, 2, 3, 4. That's going to be that point right there. Negative 1, 4.75. So negative 1, 1, 2, 3, 4. And then 0.75 is going to be like there. And then 1, 2.75. 1, 1, 2. And 2.75 right there. And then 2, 1, 1, 2, 1 right there. Okay, so we get that nice half of the curve. And we can just use symmetry, reflect it over that axis of symmetry there. So we get that point, we get that point, let's see, 1, 2, 3, so 1, 2, 3 right here, and then 1, 2, 3, 4, so 1, 2, 3, 4, oh, no, 4 right there, that's wrong. Just enough points there to get the idea. How many points do we need, Mr. Wimmeyer, to graph these? I would say minimum, I would like you to do the vertex and then 2 more points. So 3 total, I guess, right? And by 2 more, I mean the vertex and then 2 more on one side, so that way you get really 2 more on the other. So, I mean, if you want to count that as 5, I guess, but really you're only doing the work for 2, and then you're just doing the reflection there. So, you know, I would say the vertex and then at least 2 more points in addition to that. Just to get the idea. Okay, but there it is. And then, of course, draw your arrows. Okay. Questions on any of that? Any questions on that? All right. There's one more form here I want to show you, and then we'll be done. And that is intercept form. Okay, intercept form. Right, and that is when we have things of the form y equals, there's that a again, x minus p, x minus q. Okay, you may remember taking a quadratic that was in standard form. Right, you may remember taking a quadratic that looked like this and factoring it to look like something like this. Okay, so that's basically what that is. It's just the factored form. It's the factored standard form there. Okay, when you have this form, it's called intercept form because you have the x-intercepts. The x-intercepts of your graph are at P0 and Q0. So those are 2 points automatically. P0, Q0. Okay. What else do I want to say here? Oh yeah, the vertex x-coordinate is going to be x equal to P plus Q over 2. It's just the midpoint between the 2 intercepts. Again, that's because of symmetry, right? If the vertex is in the exact middle of the parabola, and we have these 2 x-intercepts, then if you go halfway between the 2 x-intercepts, that's your vertex will be on that x-coordinate there. And of course, you can find the y-coordinate by plugging in the x-coordinate there. Okay, so let me just do, I want to do something not that too crazy. Okay. Let me do a real quick example here. So let's say we've got like y equals x plus 3 times x minus 1. Okay. Well, if you look here, x plus 3, that means our p is going to be what number? If we have x plus 3, then p will be what number? Minus 3 or negative 3. Exactly right. So we have the coordinate negative 3, 0. And then what's our q here? X minus q, so the q is just what? 1. So we have those 2 points, and so we can go ahead and plot this graph here real quick. All right, negative 3, 0, 1, 2, 3, and then 1, 0 right there. Okay, again, they're x-intercepts, right? So they're on the x-axis. the vertex. Okay, well, we're going to do that negative 3 plus 1 over 2. So negative 3 plus 1 is negative 2 over 2, which is then just negative 1. So the axis of symmetry, that vertex, is going to be somewhere along this point, negative 1. We can find the y-coordinate by plugging negative 1 in for the two x's there. So y equals negative 1 plus 3 and negative 1 minus 1. So we get 2 times negative 2, which then is negative 4. So we have the point negative 1, negative 4. And so we can just plot that now. Negative 1, and then 1, 2, 3, 4. It barely fits. Okay, and if you need to get more points, you can get more points here. I'm okay with us graphing it at this point, though. I can just kind of like go like that. And go like that. Okay, it's not great, but there we go, it's better. And there's our parabola. All right, so I'm going to give you guys, just wherever you have space there, I'd like you to try and just graph these two. I know we don't have a whole lot of time, so I'm just going to give you 2 to try, and then that'll be it. I'm also not going to give you any homework on this. I know, right? You're going to have like 2 days, and the whole weekend, no homework. So yeah, I know. I'm a terrible human being. I know. Worst class teacher ever.
Egregious human rights violation.
I know, right? You guys should be like demanding this from me. Like your parents pay good tax dollars so that you can, you know, work and get things done, and I'm just letting you slack. But that's okay, I guess. Okay, so then I'm just gonna have you graph 2 things here. So graph. I'll give you one in standard form. Okay, y equals let's do this one. X squared plus 2x plus 1. Okay, so that's one of the ones I want you to do, and then I'm going to have you graph another one here. And we'll put that one in vertex form for you. Okay. So I'll give you a stupid one and then a not so stupid one, maybe, right? Here, I'll have you do this one. Y equals negative x plus 3 quantity squared plus 5. Okay, so don't forget there's a negative there in front of that. So go ahead and graph those 2. Yeah, you want some more graph here? Yep, no problem. So just get those 2 done and that'll be that. Okay, we'll go over it too. Just enough time. I'll get mine done real quick and then I'll come around and help people if they need it, okay? Okay. You can, but I would do that at your own risk. I would suggest you put it back there by David's head on the shelf, just because I don't want anyone to mess with your book, Greg, that's all. Not that anyone would, but you never know, you know. You want to find the x and y intercepts, or you just want to find...
No, the x-intercept over there.
So to do that, if you press second trace, it's the same thing as a 0, right?
Yeah.
So you go to that, and then you see it saying left bound. So if you want to find like this 0, you go to the left of that one, then you go to the right of it, using your arrows, and then you go to guess it, you just put it close to where it is, and then hit enter. And then boom, there it is. You can see it's not going to be very nice numbers.
Okay.
And you do the same thing with the other 0 again, but now you want to arrow over until you get close to the other one, left of it, right of it, and then guess it. Okay?
Thanks.
Yeah, but that's going to be, yeah. We don't always solve for the x-intercepts for a reason, Greg, because sometimes they're not very nice to graph, which you can see there as an example. That's why we try and come up with these other ones where we get some nicer numbers.
Yeah.
Okay. One more minute, folks, then we'll go over